Okay, so welcome to another JSON office hours here. My name is Beda. With me, I have Madhu and Julian. Herman might join a bit later, but we also got Chin here and Josh. So if there's any questions regarding these technologies, we're very well covered to go as deep as you want. And today, why isn't the next button working? Like, okay, I have to use the keyboard. So today we're gonna quickly glance over, or do an overview about new things that we did in 23 AI, but just very briefly. And then we go into the concept of JSON collections. Not entirely new in the Oracle database ecosystem, but we built something very new that will really simplify a lot of aspects with working with collections. We, as usually, have some demos, and then we will also talk about JSON relational duality, which happens to also be collection. So there will be another demo, and then we will have plenty of time to answer your questions. So you may have seen this slide here. It is the slide that we put out for 23 AI, which lists all the different features we have in AI, like vector, whatever. I took the liberty of modifying the slide and just putting the new JSON or MongoDB API related features on this slide. So you see we innovated in many different areas. So if you're coming from 19C, a lot of people go to 23 AI from 19C. They skip the innovation release 21C. So they, for example, will have the JSON type. We have like JSON relational duality. We have now support for JSON schema. There is this whole AI vector business in 23 AI, and we fully support that with JSON. So not only able to convert these vectors to JSON, but even have a way to efficiently store and query JSON components or vector values inside JSON. So you can have like a JSON document where inside of the JSON, you may have like an embedding, which is a vector that describes this document, or something else that, like if you describe an image, for example, with a JSON document, then you may also embed the vector for that image in the same JSON. We've added things to PL SQL, like record collection mappers. We improved smart scans. There's JSON and property graphs. The JSON search index got better in syncing. On the Mongo API, this is like this gray color. We have much better support for indexing now. We support the aggregation pipeline. And if we mean supporting the aggregation pipeline, what we basically do is we take MongoDB's aggregation language and translate that to equivalent SQL. We can also directly run SQL from the Mongo API. So if there is someone uses the Mongo API, they can issue SQL commands through the Mongo API. So this is just a very short overview. We could do like a deep dive into any of these areas, but we want to start with looking at these JSON collection tables. And for that, we briefly want to motivate why developers like to work with this JSON document model. So as we keep talking about for years now, there's developers who work with a relational model that's well established since like 30, 40 years, but maybe 10 years ago, this JSON document model became really popular. And the reasons are manifold, but they include like really schema flexibility, ease of use. So you can store data, query data, work with data without having to define a schema upfront. So you could think about if you're an application developer and you go the relational route, you usually start with data modeling, you create some tables in the database, and then you use these tables in your application code. So you can say the application grows outside of the database, or it grows from the database into the mid-tier, into the UI. And very often developers want to do it the other way around. They say, hey, I want to start with a UI. I want to define, or I want to work with my customer to agree on the UI. And then the UI can very easily, or these objects can be converted to JSON. And if I can just throw my JSON at the database, store it, query it, then it's a lot easier. So this JSON makes that development style much easier. Another benefit is also that it easily maps your application objects to and from JSON. So very often you have an object which has, let's say, nested structures. You say, oh, I have an order, and the order has a customer, and maybe the customer has addresses. So if you map that to the relational model, what's called normalization. Often you may end up with many tables for one object. So if you have an operation on one object, it may mean you have multiple operations on the underlying table. So that adds quite a bit of complexity. It's often hidden with ORMs. So ORMs create a similar use and feel, but often they just don't hide it fully that your business objects are mapped by many tables. So here, being able to say, I can directly take my object, map it to a JSON and back also simplifies a lot of aspects. And on the API side, if you want to interact with the data, then SQL is extremely powerful. It allows you to run arbitrary queries, grab columns that you're interested in from many tables, join them. But for simple operations, if you just want to find a customer based on the ID or an address on the zip code, often it's a lot easier to have a simple operation where you say, oh, I have all my customer data in a collection called customers, and that has a get by ID or some find method, instead of writing like a longer SQL statement, which especially is also most often like a string in your programming language. So for example, if you had a typo in the statement, actually there is a typo, you see where is not written correctly. If this was a Java statement, Java wouldn't complain about it, right? It would just compile it and then you would get like a runtime error. Whereas with these direct API calls, you have a better integration into the programming language. So this now brings us to this collection model. And again, I forgot to say, you're free to ask questions. I think we do have a Q&A or a chat. And Julian and Madhu, if you could just look if there's any questions in the chat, and obviously feel free to interrupt me if I'm too fast or if you see people have questions that should be addressed immediately. So now I've spoke about like documents. Developers like to work with documents, and documents live inside a collection. So let's look at this collection model. And I'd like to point out that this model was really made popular by MongoDB. I think this document model is older, and other databases like Couchbase, etc., provide very similar models or the same model, but most developers would associate the JSON collection model with MongoDB. And it's actually a very simple model, and think of this as a different mental model than, let's say, the table and column and row model. So this is just a different way to think about how your data is stored and accessed. So let's go over this. Let's define what a collection is. So a collection is basically something that contains JSON documents, and the collection is identified by a name. So I could have like a collection customer or a collection, I don't know, orders, my pets, my bicycles, etc. And you can usually associate a JSON schema with a collection. So it's possible, but most of the time it's not done. So you can take your bike data and put it into your customer data, vice versa. So they're unlike the relational model where everything has a schema. Collections usually do not have a schema. So it's really then up to the application to make sure the documents end up in the right collection. But having no schema also means that it's easier to evolve these documents. So if you start out with your customer documents having a first and last name, and then you realize some people have a middle name, well, you just add those to these documents. You don't have to make any change to the collection. So if we look at the documents, they are identified. So they have an identifier. Usually that's a field inside the JSON, for example, a field called _ID. And this solves the key value use case. So the document model is a superset of the key value model. So key value means there are values that you can just retrieve by an ID, but you can't really look inside. And you can do the same with documents because they all have an ID. So the ID is unique per collection. So if you insert something into a collection, you can provide an ID. So it can be, you could say, for example, well, the ID is is a composite key consisting of first name or last name, or it's like some customer ID that I'm maintaining. And if you don't provide it, the database will automatically add one. So after your insert or update, it's guaranteed that your document have an ID. And it is also indexed so that you can do very fast ID-based lookups. And another property is it's immutable. So if you have a document where you say customer 10 is Julian, and you make an update, then you cannot change this ID value. So if you want that document to have another ID, you would have to delete it and insert another document. So the identifier is immutable. Exactly. And having this ID really allows you to do like these key value operations, like simple, like a replace or an update or a delete or a get based on ID, similar to a key value store. But you can also use this ID to replicate documents across databases, or if you have a cache, you can invalidate a cache based on an ID. And at the end, if we summarize this, then these collections are allowing for simpler APIs because you can because your backend data model collection, every collection kind of looks the same. It may contain different data, but if you define an API that works with collections, you can use it for all kind of data. You don't have to define with like different tables, different SQL, different shapes. So this really simplifies the API, makes access more uniform. And now this was like just the concept, like what is a collection? And now we look at how we can implement collections in Oracle and how we did that in 23AI. But maybe let's take a little break. I want to ask, are there any questions so far, Madhu or Julian? No. Okay, then let me go. So now if we step back a little bit and we look at JSON in Oracle database, then there's basically two different ways how you work with JSON. One is you store JSON. So this is what we allow since release 12.102, where we added like JSON storage in a club or a blob with this JSON check constraint. And then later in 21C, we added the JSON data type. So now you can say, I want to have a table, and inside there is like a column here, we call it data, and that stores JSON in a binary format, like JSON type uses an optimized binary format, we call it OSIN. And now you have like JSON in, JSON out, and you persist JSON on disk the way you like whatever your JSON looked like when you inserted it, it's stored as is. The other way on the right side is where you don't store JSON directly as it looks like, but you instead map it to relational columns. So we also had this since 12.102 as a way to read JSON from underlying relational data. So we call that like JSON generation. The SQL functions are a JSON object, JSON array, etc. And since 23AI, we can also do writes because these are basically duality views. So you can map JSON data to underlying relational tables. And if you bring now this collection concept into the picture here, then you can say, well, I want to work with JSON collections. This is this mental model where I say I have documents in a collection has a name, etc. Then there is two implementations. One is to say I store it, that would be the JSON collection table, or I map it, which would be the JSON collection view. And we're going to look now into JSON collection tables. That is something we added in 23AI. So it's a variant of a table. So there is a new syntax. You can say create JSON collection table, and you give it the table name. And under the cover, it will create a table with that name, and it has one column called data, which is of data type JSON. It can only accept JSON objects. So if you try to insert a JSON scalar or a JSON array, it will reject that. And you can not add any other column. So it is unlike a regular table. So you could also create a table and you list all your columns, and then you could add one or multiple JSON type columns. Here it's really like one fixed shape. So you say, I'm creating this table, it has this name, and it's really there for the collection use case. So it is possible to add invisible extra columns for partitioning or sharding. But those would really be more like machinery columns to enable like the functionality of partitioning or sharding. Your app wouldn't directly work with them. This is why they are invisible or hidden. And if you insert something into this table, we will check if your JSON object contains an ID. It will then check that it's really unique. So an insert would fail if you already have a document with this ID. And if your inserted document has an ID, we will preserve it. So you can choose to define your IDs yourself, or you can just insert documents without an ID, and then the database will add this ID for you. But basically, once a document is inside the database, it does have an ID. And this ID uses hashing, so it's not a sequence, and this is to avoid hotspots. We can also use an optional eTag, so you see this optional clause with eTag. And this allows, similar to JSON relational duality views, it's used for optimistic concurrency control. So what it means is you can, for example, make a REST call and say only update this document if the version is still current. And the way it works is there is a value injected into the document that we will compare on an update to check if this is still the latest version. So if you learned about JSON duality views, then a lot of this will look very similar here. And maybe let's now look at a demo, how we create these collection tables. And I urge you to really to look at the ease of interoperability. It will be now very easy to work with the same data using collection API. So we will be showing like the Mongo API here, but you could also use Soda or REST. And it's really easy to work with the same data using SQL and these collection APIs. And with this, I hand it over to Madhu.
Thank you, Veera.
Yeah.
I'll share my screen. Can you see my screen?
Yes.
Okay, so I'm going to show you a short demo to demonstrate the interoperability between Oracle's native collections and SQL and how it can be used interchangeably with Mongo commands. So to do so, I have an Oracle Database 23 AI instance set up on Oracle Cloud, and we're going to interact with it using MongoDB Compass. I've established a connection between Compass and Oracle Database using the Oracle Database API for MongoDB prior to this demo. So during the course of this demo, we'll be creating two collections, employee and department. We'll be running a series of commands on them, half of them using SQL statements and another half using Mongo commands, just to show that both of them can be used interchangeably for the exact same purpose. At the start, I have a SQL wrapper function, which I'm going to use to be able to execute SQL statements from MongoDB Compass. So this is the Mongo shell I have here within MongoDB Compass. So the first step is to drop any pre-existing collections. So you can see here in the current schema, you do not have any pre-existing tables. And I'm also going to enter the SQL developer within Oracle Cloud. And you can see that it does not have any user-created tables at the beginning. Now we're going to create two collections, one using Mongo's create collection method. So I'm going to create employee using create collection, and another collection called department, but we're going to create this using SQL syntax instead of create collection. So create JSON collection table department. And if you refresh both the user interfaces, you can see that two collections have been created. Now I can run these SQL statements either on MongoDB Compass or on SQL Developer. I'm choosing either of them just to show that either of them can be used interchangeably. And we just saw the collections on the user interface, but you can also run get collection names to view the collections on the Mongo shell. You can see two collections, department and employee. And you can also run the SQL query, select collection name from user JSON collection tables to view both the collection tables. I could also run the same thing from the Mongo shell. You can see two collections here, department and employee. The next step is to insert some records. So we're going to insert 3 records using Mongo's insert many command into the employee table. We have 3 records inserted. You can view it from the SQL developer shell. So you can see 3 JSON records here. An important thing to note is that the underscore ID was not present in the input document, but it has been auto-generated, and each document now has an underscore ID field. Similarly, we insert a couple of records into the department table, but now we use the SQL syntax. And you can again view the record. So you can see 2 departments, department number 1 and 2, inserted. Again, the underscore ID field is auto-generated. The next step is to retrieve the records. We already saw it in the SQL developer shell, but you can also use Mongo's find method to view the records. And you can see 2 records inserted into the department table. Next, we'll be creating a couple of indexes, one each on each of the tables, and we'll be running a couple of queries to check if the index gets picked. I'm creating the first index using SQL syntax, create index, index name on table name, followed by the JSON value expression. So the first index is for the employee table. And the second index is on the department table. I use Mongo's create index statement for that. Next, let's run a couple of queries to check if the index gets picked. So the first one I run is on the department table. I'm going to run a SQL statement to check to view all the departments that have department number as 2. And you can view the execution plan for this statement. I'm going to query the plan table output. And if you look at the execution plan, you can see that the index on the department table has been picked. You can also view the same thing on SQL Developer in a nicer user interface. So if you look at the execution plan, you can see that the index on the department table has been picked. And we're going to run a similar query on the employee table. So I'm going to find all employees of name Jane Doe. It should have. And we're going to use explain to view the execution plan for this query. We're going to use Mongo's explain command for this. And if you scroll up, you can see that the index has been picked. So you can see that you can either use the SQL create index or Mongo's create index to achieve the exact same purpose. And the last thing that we're going to see is update. So if you look at the department records, you can see that the second one does not have any contact field in it. It just has department number, department, and underscore ID. And you can see that the underscore ID ends with 599DD. So we're going to add an additional field to the second record, which is the contact field. So I'm going to use Mongo's update one command to update department number 2 and set an additional contact field. So here you can see that the second record has an additional contact field now. And an important thing to again note is that the underscore ID field has not been changed during this operation. So we used Mongo's update 1 to update the record. You can also use the SQL update statement using JSON merge patch to add an additional field to an existing record. So let's do this for the employee table instead. You can see that the second record does not have any email field, and we're going to use the SQL update statement to add an additional field. And if you query employee now, you can see that an additional email field has been added for the second record while making sure that the underscore ID field does not change. Lastly, in order to drop the table, I'm going to do one using SQL drop table syntax and another one using Mongo's drop command. So let's drop employee using SQL syntax. And let's drop department using Mongo syntax. And if you refresh both the user interfaces, you'll see that the tables do not exist anymore. So yeah, this was a short demo to show that you can use the new JSON native collections interchangeably with SQL syntax. Thank you. Back
That was
to you,
excellent,
Veera.
Madhu. I had a big smile when I saw that explain plan, like the Oracle explain plan in that MongoDB tool. I just like to see that. Like that's really shows how deeply the interoperability works, right? So you can really choose. Like there was quite some active chats going on. I think most of it got answered, but some people had like basic question like why do we even do this? And maybe I missed that in the introduction, but the document or collection model is also one of these NoSQL models. And what we've seen in the past is that many people think they have to choose between the relational model and a NoSQL model like this JSON model. And choosing means that they often choose a different database. And the reality is that there are just, besides looking at your data as rows and columns, relational, or looking at it as JSON documents, there is also the dimension of use cases. So you may work with individual records, or you may have to do some analytics or reporting where you look at many data in the aggregate. And what we've seen from many customers that choose to use a JSON-only database or a NoSQL database, that very often they want to run some reports, and then they have to move that data into a relational database or into another database that is capable of running these operations across documents. And what we, what really is our team's mission is to give people like a good JSON experience that is fully interoperable with SQL. Meaning if you store your JSON documents in Oracle, you can store them in a table or in what we have now added a collection table, but it allows you to access that same data using these document APIs, as well as SQL for reporting, analytics, etc. So that is really the value add we're trying to give customers, that we say, hey, we're a data platform. Depending on who you are, you may be a data analyst, you want to run SQL, maybe in a tool like Tableau, whatever, or you're like a developer that prefers to use REST or the Mongo API or any other document API. We try to, we want you to have all these options in the same product. Okay, so then let's continue the presentation, I guess. So quite an active chat, that's good. And some of you may have worked with Soda, and you're asking, hey, this is all not brand new. We had that since 12.1. It's called Soda, which stands for Simple Oracle Document Access. And that's right. So Soda is an API we provided early on. It was conceptually very close to the Mongo API, but it was not really compatible. So we added later this MongoDB compatible API on top of Soda. And Soda allowed a lot of customization. So you could choose how to store your JSON, what is the name of the columns. It also allowed like some optional other names, like when a document was updated. And what we do in 23 AI is that we say Soda collection. So if you use Soda, like a Soda collection will now be a collection table by default. So Soda remains fully supported. And Soda is now one variant of these collection tables. So these collection tables have like a fixed shape. We think this simplifies things. So we recommend people to go out with these collection tables. And they're backed by JSON type. They're fully integrated with SQL, like Madhu showed. What's also possible is to do direct insert. So you can do like a insert as select into a JSON collection or then into a Soda collection, and it will auto-generate the key. This was something that Soda didn't do as nicely prior of 23 AI. So if you want to continue using like these old Soda shapes, then that is still possible with custom metadata. But we really recommend to use that new, simpler shape going forward. Like if you already use Soda, nothing changes for you. If you start using Soda, it will be backed by JSON collection tables. So we're still continuing with Soda. So now let's look at this slide again. We said, hey, a JSON collection, it's this data model where I have JSON documents in a bag called collection. We looked at JSON collection tables. Now let's look at collection views. And a good example of a collection view are actually these JSON relational duality views, which I quickly want to recap. I don't want to spend too much time on it because the time is progressed already a little bit, and I want to make sure we do have a demo. So what we do in JSON relational duality is to not store the JSON as is in a column, but instead mapping it to a relational model, meaning you have a normalized model with data stored as rows and tables. One benefit is if you have an existing application, you can easily add JSON relational views on top and easily JSONize or REST enable these applications. So you start with a relational storage. You can have like JSON columns inside. If you have like schema flexible content, you can also have our new vector data type. And then you can define as many JSON access views as you want. So you can say, hey, I have so the example we use here is for a school it's a conference. So you have attendees that visit a conference and you store your data in different tables. So we have a table for attendee information. We have like a table for session. We have a table for speaker, and they're joined through this mapping table. And you can write a view definition that joins these tables to generate a JSON document of the shape you want. So the example we have here is we want to build a schedule for a person. So we have this underscore ID that defines the object in the collection. So the collection would be the duality view. So a JSON duality view is also a collection. You have some information about that attendee, like the name, the company they work for. And then there is a schedule document, which is a nested array, which lists all the conference session that a person has put on their schedule, together with information about the room and the speaker. And that information is not stored as this document on disk, but instead it's mapped to these relational tables. So the benefit of this is by storing the data in separate tables, you can assemble it into different ways so that this schedule is just one way to assemble your data. So you could say, I have another JSON document which lists all the sessions that I offer in this conference. Or you could say there is another document variant that lists the schedule for a speaker. And by storing it relationally, you guarantee consistency, meaning that if you make a change through one duality view, it is reflected in all other duality views. So how does this work? So I basically have my storage being relational, and then I pick the tables and the columns that I'm interested in. So here, for example, from that attendee table, we only pick the name and the company and the identifier. We don't pick the phone number, for example. So this is another nice aspect of these duality views, that depending on the use case that I want to solve, I just pick the information I need. So, and you can create as many views as you want. So you could have another view which allows you to maintain the phone number of an attendee. Then the other nice part, I can also allow what parts of that document I'm allowed to update. So for this schedule, I want, or for this schedule view here, attendee schedule, imagine there is like a web interface which allows people to add sessions to their schedule or remove sessions to the schedule. All we want to do is able to add like an object to the schedule array. We don't want people to change the time or the room. And what we allow with duality views is really fine-grained update rules. We can say, hey, you can only update this part of the document, not other parts. And this is, again, a difference to persistent JSON. If you store JSON as one unit, then you do not have this fine-grained update rules. You can either update a document or not, but we cannot limit it to certain parts of it. And then I also have like some structural properties where I can merge data. But at the end, what you do is you define such a view on top of these tables. And if you query the view, it will give you that information as a JSON document. And you can make updates. So it is not only a read-only view, it is actually an updatable view. So if you make any changes, we will figure out what the underlying updates are on the base tables and update those. So the data will always be consistent and only stored once. But if we look at this JSON duality views, and you may have heard about this before, then the conclusion is JSON relational duality views are really collections because they satisfy the criteria of having a collection identified by a name, contain JSON, everything has an identifier. We have these simple APIs, like I can access duality views from the Mongo API, for example, and we have support for ETAG. So what this means as a conclusion is JSON collection is really an abstraction over the actual storage. So it's similar to Java, where you define an interface and you work against the interface, and then you can have different implementations of the same interface. It's the same here with JSON collection. So you can say, for this new project, I really want to use JSON. I write it against JSON collection APIs, either SQL or Mongo API or Soda. But then I still can choose whether I want to store the data as JSON on disk, so use JSON collection table, or if I want to map it to relational tables. And you can even change the storage as you go. So one example would be you have like an agile project. So you start persisting the JSON data. Once your application is stable and you want to enforce more integrity across the data, if you make an update in one collection, you want that change to be visible in other collections, you can easily migrate from persistent JSON to JSON relational duality using a tool called the document migrator. And Julian will demonstrate this now. Over to you, Julian.
Thank you very much, Peter. Give me a few seconds just that I share my screen.
Yeah, it's still open.
All right, let's start. So very much like what you saw until now, I'm going to use an Oracle database, and it is a 23.5 Oracle database. Here you can see the banner full from V version. In SQL+, I'll be using connections from SQL Developer. Here is SQL Developer to the same database, SQL+. And I'll be using also the same way also connections via Mongo Shell. Let me show you the connection via Mongo Shell. Here it is. I'm connected to the database. And of course, also using MongoDB Compass. Here I have the same connection to the same database. So it's a 23 AI database, 23.5, the latest version. And I'm going to demonstrate two things, a couple of things. The first one is how you can create duality views based on collections. What we're going to do is do it only with one collection. Of course, you can migrate several collections to duality views. For the sake of time, I'll be using only one collection. And I'll be using what Beta just mentioned at the end, the new tool from Oracle called the JSON to Duality Migrator. It is a PostSQL-based tool. So let's start from the beginning. Let us first create in SQL Developer the collection, an empty collection called Conference Schedule. Create JSON collection, table, admin conference schedule. Here it is, JSON collection created. What I'm going to do next, I'm going to show you the collection. Here is what it looks like, the collection. I'm having 4 different presenters. Beta, who has a schedule of 1 presentation on JSON and SQL, another 1 presentation on PostSQL and JavaScript, another presentation on Oracle iPhone and MongoDB API internals. Then we have Herman, who is answering vigorously questions in the chat, who is here. He will be joining 2 presentations, PostSQL or JavaScript, MongoDB API internals. We have Ranjan, who has nothing, and we have Julian, who is only attending JSON duality views. What I'm going to do is I'm going to use Mongo Shell, and I'm going first to refresh in order to see the conference schedule collection. I'm going to use Mongo Shell, Mongo Compass, MongoDB Compass, to import the collection. If you have not used MongoDB Compass, you click on Add Data, and you have 2 options, import JSON or CSV file, or import document. I have the JSON file. So I'm going to pick up the document that I just showed you, and that's very much like SQL Loader in Oracle, and I'm going to hit import. Stop on errors. I'm pretty confident I won't get errors, so I have 4 different documents imported. As you can see, import completed, 4 documents imported. So I have those 4 documents. Imagine you're migrating from MongoDB or any other document database. You need to have first the collections inside the Oracle database before you can proceed. What we're going to do next, we're going to use the API in order to migrate the collection, conference schedule, to duality views. I can do it for in several ways, but I'm going to use SQL Plus. And it is just 1 procedure. As you can see, I'm using the new Oracle package called DBMS JSON Duality. It came in 23.4, so it's available in 23.4 and 23.5. And it comes with 3 functions and 1 procedure. Usually use this procedure, infer and generate schema, to generate the duality views based on collection names. So table names, you can list them one after each other. I have here only conf schedule. Then I'm using 2 parameters, use flex fields, updatability to false, and source schema is admin. This is the user that I'm going to use. So updatability is an optional parameter. It's a Boolean value that determines whether the duality view to be generated should be updatable, that's true, or not false. And when true, annotations are set for maximum updatability for each view. Each view, when false, like in the case we're doing now, they are created as read-only. So the views are created read-only. And the use flex fields, which is also an optional parameter, is a Boolean value which shows whether flex columns are to be added in the tables underlying the duality views. And when it's set to true for each duality view, a flex column name is or a $view name flex. It's being added to each table, to each relational table. The default for both are true. I'm going to use them for false, doesn't matter. I'm using DBMS output put line to show you the DDL script that is being generated, so it is being run. And I'm going also to put also the schema SQL. I'm going to use execute immediate at the end. I'm going to execute immediately the schema SQL. That's the long statement. And then I'm going to import the data into the duality views. In fact, I'm not importing the data into the duality views. I'm importing the data into the tables underlying the duality views. So everything works fine. This should come with PostSQL procedure successfully completed. And this is all. This is very simple. That's the way how you migrate collections to duality views. You see, it's just one procedure which you run. Now let's validate the newly created object. So let's go to SQL Developer and let's see what we have. Let's see if we have the conf schedule duality created, _duality. Here it is. You can see the duality view is created. If we want to check what objects were created from this automated procedure, you can select everything from DB objects for own admin and object name like schedule. So I'm trying to filter on what is being created. So note also that even the foreign key was created here. So Oracle automates everything. And then if I want to see what is in those newly created tables, relational tables that Oracle created, we have a new table called ComSchedule. And then we have, you can see here that we have the names of the presentations, the speakers, the locations, and then we have the sessions IDs, the speaker IDs, and so on. And of course, if I select also from the newly created table ComSchedule root, I can see that I have the names of the 4 speakers. All right, so let's continue. This was example number 1. Of course, I can do something else probably in less than a minute. I can also go to Mongo Shell and verify the number of documents that were created in the ComSchedule Duality collection. So, of course, we want to have 4 documents because there were 4, just showing.
Are you sharing it? Oh, yeah, there it is. Okay, good.
Here it is, yes.
Yeah.
I'm sharing it, yes.
Yeah.
So I'm the admin user. I'm counting the documents in the schedule duality view for everything correct. All right, so this was the first thing. The second thing I want to show you is if, for example, you need to migrate from MongoDB or from any other document store that uses JSON documents, there is new Oracle Big Data Adapter for external tables. It can stream external JSON sources into the database. It makes it very easy and efficiently to load JSON in text files. So I want to show you how you can move a collection and using external tables, you can load it into a collection into the Oracle database. So this will be very useful if you migrate on-prem a Mongo database, MongoDB to Oracle. So the first thing what I'll create a JSON, I'll create a directory for the objects I want to create. So I'm going to use create or replace directory. I can do it, for example, via SQL+. I can use also SQL Developer. So I create a directory called JSON files. I need to store the JSON file somewhere. I created here the directory. And then I need to move, of course, the file to the database server. So I'm going to use a collection of movies called movies JSON. The movies JSON contains almost 4,000 movies. It's a 5 megabyte file, which I already transferred to the server. So it's already here. I did transfer it. You can transfer it from any machine. I had it locally on my hard drive, so I transferred it to the database server. And the next thing I'm going to do, I'm going to create the table, the external table, using the following syntax. It is a new one. Have a look. Let me use also SQL+, although maybe Bida will make fun of me. Here it is. Create table, JSON file context, data is JSON, organization external, type Oracle, big data. Know that one. Location, I gave the location of the file, parallel, reject, limit, unlimited. So table created. So I have the table. Now let me create the collection. Let me now create the collection in the database where I'm going to store the data from the external table. Very simple syntax, create JSON collection table movies content. Table created. Now, let us do something. Let us insert the data from the movies content, from the external table into the JSON collection. And this might take, since it's a lot of documents, it might take about half a minute or so. Let's see. What we'll do once we have the data inserted into the collection. Of course, I have to commit the transaction. We're going to test the newly created JSON collection table in the Oracle database. We're going to check if we have any movies which contain the word father in the title. So you expect to see movies like Godfather and Father of the Bride, something like that. And you see that if you, for example, have hundreds of collections, if you have a big MongoDB, Mongo database, or any other document store, you can very easily transfer all those collections, their text files. You can very easily transfer them, for example, secure copy, anything if you want to use to the database server under a certain logical directory. And then you can create external tables for each one of those collections And then based on your logic, you can very easily copy the data into the newly created collections in the database. Let us commit the transaction 3,800 movies. So what we want to do now is, let's go now to SQL Developer and see if we have any movies from those using the word father. So we're selecting everything with title like father. We have the Godfather, Godfather Part 2, and the Stepfather. I'm going to do the same using MongoDB Compass. Let me refresh here so that I can see the movie's content. Here it is. And of course, here the syntax is a little bit different. Title should be, it's not like father, but you have to put the name, the word father between two slashes. So here it is, find. And I expect to see also three different movies. Of course, the Godfather here is the whole information about the three movies. And I think this is all I wanted to show for now.
Hey, I did not know about this /father, this like stuff in Mongo. That's cool.
Yeah, that's how the filtering works. It's not in Oracle. We have the percentage sign. In Mongo shell we have slashes. Awesome. And I think what, for example, I learned from Herman is that if we switch to autonomous, we do not even have to stage data, but we can do a simple insert as select, and that is you can directly insert the data into the table. Granted, of course, the JSON file, the movie JSON file, is already on object storage. And I think that's all from my side. Bida, and over to you.
Good, thank you. That was excellent. There was one question that Herman already answered in the chat, but I just wanted to also talk briefly about it. So some person asked, hey, if my storage is relational, how can it be schema flexible? As you know, in JSON, you can add new fields or new substructures. So you may have a table with first name and last name, and now you want to add a middle name into your JSON, and there is no column for it. Like, how does this work? And there is basically two answers for that. One answer is, and you briefly mentioned this, Julian, about the flex column. So you can assign a column of type JSON, and that serves as the overflow column. So any new value, like in this case, the middle name that cannot be mapped to one of the existing columns, would overflow into that JSON type column. And when you fetch the document back, we would look at what's in the overflow column and merge it with the document. So this way you get full schema flexibility. And one may ask, like, hey, why don't we add like a JSON type column to all these tables automatically, and everything is enabled for flexibility? And the reason we don't do that is that flexibility always sounds nice, and it sounds like it's a good thing, but it's only sometimes a good thing. So you could imagine having an application where you have multiple readers and writers to the data. And let's say you had no schema at all. Let's say you were using a NoSQL key value store, whatever, that had no ability of having a schema anyways. Then you still have a schema. It is just not in your database. It's in the code of every writer and reader. Meaning you could have a writer that decides to write some new field into your JSON, and that may cause some problems with a reader, for example, right? They may say, hey, I don't know this field or that field. I'm expecting this field to be there. You removed this field, and now an application would break. And it might even that another application, like application B, breaks because application A makes a schema change. So schema is always like, depending on who you talk to, some people say, hey, I really want to have tight control over my schema, or people say, hey, we're like a schema-less company. We're not really there to tell people use this or that. We just give them these choices. So the choice is to say, hey, I can specifically add schema flexibility to one table if I choose to. Or I say, no, this is really a closed table mapping to a closed object. And if there is a schema change needed, I will add an additional column. So it's all about control. And we've learned, especially from larger JSON projects where you build like non-trivial applications with many different use cases, that this kind of control is really needed. that if you don't have any means to control the schema, then very likely something will break. So we got like 3 minutes left. I think we covered it all. I think we're just doing like a recap. Let me just quickly go here. This was your demo. So yeah, that's the recap. In 23 AI, you really get JSON for the enterprise. You can build very complex things with the JSON capabilities we have. You now have JSON schema, you have JSON relational duality, JSON collection tables, a wide choice of APIs. You can work with SQL, with REST, with MongoDB compatible APIs, drivers. You can have our own Soda drivers. So it's a very, very powerful JSON data platform, which really allows you to build complex apps using JSON that you couldn't really build with a JSON-only database or with a NoSQL database. This is a little bit advertising for myself. Like if you want to learn more about JSON relational duality, there is a new book out there since I think last week. I'm one of these co-authors. So I don't make a lot of money with it, but right now you can get it like for really cheap on Amazon as a Kindle offering. So here we go really into some use cases. For example, when should we use flexibility and other kind of patterns or recipes to use a JSON relational duality. And with this, we want to thank you all. I think we really ended exactly on time. That's excellent. But we can stay a bit longer if there are any unanswered questions. I think there is one open question right now, Julian, if you want to take a look, because I think it's...
Kevin is already typing the answer.
Yeah, you want to take it online? You want to talk about it? It's going to be a longer answer. I can continue typing then.
So what happens if you try to migrate a JSON collection containing various documents not consistently belonging to one or to a schema, using the migration procedure to create a duality view and relational tables? Yes, I think what's happening here is that the schema migrator is basically a two-phase process. So it will look at your JSON documents. It will try to find a common schema to the largest extent possible, but outliers will go into a flex field. And then in that first phase, it will present you its findings in a JSON schema document. So it will say, hey, this is the schema that I think is suitable, but I leave it to you to take a look at it, to correct it. And then in the second phase, given that intermediate JSON schema document, we will create the tables and the schema. So are we saying you should always only use the migrator tool? I don't think the answer is yes to that. So it probably makes sense just from a data modeling point of view, if you use JSON relational duality, to understand the underlying tables that will be created, because they have effects on the sharing, right? If you have one table that participates, let's say, in 3 different views, then an update to one view has side effects to the other views, right? So let's say you have an address table and address is being used, I don't know, in customer or orders, whatever. You change an address, that change will show up in the other collection. That's like the consistency benefit, where we say you only store your data once, you only have to make update once, and it will always be consistent. But this is something you have to understand, right? That's like a semantic change from before, where you stored your JSON documents and every address was separate, right? If you had I don't know, many orders from the same person, they would all store the address separately, repeatedly. And maybe that was intentional, because that was the address of that point in time when the order was sent out. So there are some semantic implications of sharing data in duality views.
And if I can add something, Peter, to what you just said, probably I did the demo a little bit too quickly, but the whole tool, the JSON to Duality migrator, it consists of a converter and an importer. So first you run the converter and then you run the importer. And the converter also has 2 parts. It has 2 functions. One is the infer schema, which infers the JSON schema that represents all the documents that you use, all those JSON documents they use in the set that you have, you're trying to migrate. And then there is another function, generate schema, which produces the code that creates actually all the database objects for each duality view, including also the foreign keys. And then you have an importer separately, which imports the data. So that's how it works.
I was at a data modeling conference earlier this year, and duality views resonated extremely well. So what some people told me is they said many developers want to use JSON for their projects, and because of that, they abandon the relational model, and there is no longer data modeling happening. And that causes all kind of downstream problems where applications don't perform or applications cannot add new use cases. Certain queries are impossible to do because they don't access the objects directly, but something that is embedded. And what they loved about Duality View is that they can still do data modeling like they used to do this for many, many years. All their skills still apply. So they create a proper data model with relational tables, and then they define these views on top, which give their developers access in JSON format. So those people would probably not use the migrator, or maybe they use it, but they definitely want to have full control and full understanding about the data model that underlies these duality views.
Yes.
Yeah. Okay. 3 minutes over time now. Thanks a lot. And I hope to seeing you guys again soon.
Until next time. Thank you, Beta. Thank you, everyone.
Bye.
Bye-bye.
Thanks, folks. Bye.